Now let's do some examples where we're going to find angle measures or other measures in an equilateral triangle. So for this first example, this is really just going to show us another property. And this one says to find the measures of angle P, angle Q, and angle R. Well, right off the bat, I noticed that all sides are equal. And so I can automatically know if all sides are equal, well, that means that all angles are also congruent. And I want to find what all of these angle measures are. So thinking back to last week by the triangle sum theorem, I know all the angles in a triangle add up to 180. I know all these angles are equal, so I'm just going to label them all as x. I know they're all the same number. I don't know what that number is, so I'm just going to label as x. And then I know that all of the angles in a triangle add up to 180 by that triangle sum theorem. And so now I can solve this equation for x. So x plus x plus x, I get 3x. And then dividing both sides by 3, I see that x is equal to 60. So that means that angle P, which is equal to angle Q, which is equal to angle R, is equal to 60 degrees. And so that's always going to be the case. For every single equilateral triangle, an equal angular triangle, all of the angles inside are always going to be 60. And that's because all angles in a triangle always add up to 180. So for this next one, I want to find the value of x. I see all my sides are equal, so that means that all my angles are equal. I could go about this one the same way as I did for number 1 by labeling, okay, well this is 2x plus 32, and this is 2x plus 32, since they're all equal, and then add all those up and set equal to 180. You can do that, but there is a shorter way. Since I already know all of these angles are going to be equal to 60, because for every equilateral triangle the angles inside are 60, I can instead just have the equation 2x plus 32 is equal to 60. And that makes it a lot shorter. So every time with an equilateral triangle, and you're trying to find some angle inside of it, it's always going to equal 60. Okay, now I'm going to solve this for x. I'm going to subtract 32 from both sides. And 60 minus 32, I get 28. And then I'm going to divide both sides by 2. And so I get x is equal to 14. So those two, we were told they're equilateral. Now we are given equal angular triangles. But again, by the properties that we learned about in the last video, anytime you have an equal angular triangle, that means it's also equilateral. So that means also that these sides are congruent. So since these two sides are congruent, I can set these equal to each other. So 4t minus 8 is equal to 2t plus 1. And then I'm just going to solve this for t. So I'm going to subtract 2t from both sides. Add 8 to both sides. 1 plus 8, I get 9. And then I'm going to divide both sides by 2. And so I get that t is equal to 9/2. Or you could put 4.5. Either way is fine. Okay, go ahead and pause the video. I want you to try that last one. So for this last one, you should have gotten that y is equal to 18. Since this was equiangular, that also means all the sides are equal. And so I just set 5y minus 6 equal to 4y plus 12. And then when I solved for y, I got 18. Okay, that's it for this video. You can go ahead and move on to the next one where we'll be looking at using both isosceles and equilateral triangles. So we'll be using properties from both to solve those.